Okay, so our lesson today, our lesson name is trigonometric identities. Trigonometric identities. Okay, so basic trig identities is our title today. So our title today is basic trig identities. This is our title. So this is the title of the lesson. This is the first lesson in chapter 10. This is the first lesson in chapter 10. Okay. We'll start this chapter by a small revision on the previous chapter. I hope that you finish the worksheet that I leave in SBS in order to cover all the information or the previous information. Inshallah, our exam will be after 2 weeks from now. After 2 weeks, inshallah, from now. Okay, so please try to finish the lessons, okay, and try to finish and print all the materials, the sheets that I send it on the SBS in order to collect all the information and get a good mark, inshallah, in the final exam. Thanks, and we will start together. Today, inshallah, we have a small electronic homework also. Okay, we need to participate or react with this homework. I send on the group the last or the final homework report for the previous week. We'll start together by this problem. We'll start together by this problem. Okay, I need to rewrite 240 in radians. I need to rewrite 140 in radians. I'll start with Musa.
Yes, Mr.
Okay, I need to change this degree measure into radian measure. What shall I do?
It was the angle.
Yes, multiplied by
pi
over 180.
Over 180, yes.
So I need to multiply 240 times by over 180. If you calculate it or simplify it, you will get?
I will do it now.
Yes, okay, I'm waiting. Equals
4 pi over 3.
Yes, 4 pi over 3, letter C. So the answer will be letter C, 4 pi over 3. Okay, thanks,
Okay.
Musa. We're going to the next example. In the next example, as you see, I need to get the exact value of tan negative 120. Abdullah Laid.
Hello?
Hello, Abdullah?
Yes.
Okay, Abdullah, start. I need to find tan negative 120.
We first add 90 plus negative 120.
Add what?
90.
Add
Right?
add 360. I get the coterminal angle first.
Okay.
The coterminal angle, you must add or subtract 360. Subtract if the angle is more than 360. It means I'll take one revolution. Or in the other, if you have a negative, we will add one cycle in the positive direction, we will get the angle. So it becomes tan after adding 360. so becomes 10.
10 480.
No,
Negative 100.
no, add
Negative.
360 plus
Add.
negative
Okay.
180
240.
equal 240. Okay,
صوتك
so 240 or 10 240
calculator.
it
It means root 3.
root 3 and this tan, it means tan 60. If you need to relate it to an acute angle, it's 180 because it's in the third quad, so we related 180 plus 180 plus what? Plus theta. Theta is 60, so we can get it by tan 60. As you said, tan 60 is root 3, and we deduce that 240 degree in the third quad, and in the third quad 10 is positive, so root 3 is positive, as you see. So the answer, as you said, Abdullah, it's root 3. Okay, Khalid Al-Harbi. Okay, Khalid, you have any problem?
Mister, this is the revision of the last chapter, right?
Yes.
So today, no new lesson.
No, we have a new lesson, just a small revision for 3 or 4 problems, and then we start the new lesson.
Okay. One question: from where you get 240?
We get 10
Plus 360?
Plus 360. So we add here. So I add to this angle, I make a plus 360. Okay. To get positive angle. After we get positive angle, we deduce this positive angle in the third quad. In the third quad, it's 180 plus 180 plus what? Equal to 140, 60. So get 10, 60. It will be root 3. Okay.
Thank you.
We're going to another example. Okay. Hussein.
Yes.
Okay, can you read the example, please?
Okay. Georgia is watching a space shuttle lift off from 0.5 mile away. When she looks up at the shuttle at a 60 angle, how high is the space shuttle? So we draw like small triangle.
Yes, okay.
Or small angle.
Right angle triangle.
This is an elevation angle.
Yes, excellent. So I'll draw with you. So we have here a right angle triangle. So we draw the right angle triangle. So this is a point of elevation. This angle, as he said, it's 60 degree. It's an angle of elevation, as you said. Okay. And this distance is 0.5 miles. Okay, I need to get the height here of the shuttle.
Sure. So we can get the hypotenuse, which is equal to 1 mile.
Equal what?
1 mile.
Okay, there is no problem. Okay, if you need here to get the hypotenuse, because Hussein did use that, it's a 30-60 triangle. So the side which opposite to the angle 30 is half the length of the hypotenuse, so it's 1. So after that?
So according to the law,
Pythagoras?
I won't say Pythagoras because I forgot the law. The law states that the angle opposite to 60 degree, the 30-60 triangle, no. The side opposite to angle 60.
Yes.
Is root 3 divided by 2 of the hypotenuse.
Okay, so it's equal to, yes, it's equal to 0.5 or half multiplied by root 3.
Yeah, no, root 3 over 2.
Yes, root 3 over 2 multiplied by 1.
Yes.
Or half multiplied by root 3. It's the same.
Okay.
Okay, equal to?
Equals to 0.87.
Yes, so it's the second answer. By this way, Hussein stand on the special case triangle, which is 30-60 triangle. We can use another way. We can use the way of tan. So this is our angle. This is our angle. Our angle is 60. I need to find the opposite, and I have the adjacent. So if I write here tan 60, if I write here, it's another way to solve the problem. Tan 60, it's equal to, for example, it's x, the missing height, over 0.5. So you can find x, which is the height we need, by multiplying 0.5 by tan 60. Okay, tan 60 equal root 3, as Abdullah said from the previous example. So I have multiplied by root 3, it's the same answer. So as you depend on the special triangle, or by using the trig functions, you can find the result. Thanks, Hussein. Okay, we're going to another example. I think it's the last one. I'm going to Abdurrahman. 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 Are you with me, Abdurrahman?
Yes, yes.
Okay, Abdurrahman, I need to find the amplitude and the period of y equal to cosine theta over 4. What about first the amplitude?
What, mister?
I need to find the amplitude of this function.
The amplitude.
The amplitude is the coefficient of the function. The coefficient here is what?
Number 2.
It's 2. So the amplitude is 2. So about the amplitude, we get it as 2. And the period. What about the period? The period,
4.
The period is equal to 360 over the coefficient of the angle. The coefficient of the angle is what?
It's 4.
It's not 4. It's 1 over 4, because 4 is down. So it's 360 over 1 over 4. If you calculate it, it will be equal to 8 by. So now we have, Abdurrahman, the amplitude is 2 and the period is 8 by. So it's letter what?
It's letter D.
It's letter D. Okay. So to get the amplitude and the period, just we take the coefficient of the whole the function. It means the number before sine or cosine or tan and something like this, and also the coefficient of the angle. This is the answer of this example. Okay. I'm going to the last one. Al-Walid.
Hello.
Al-Walid, which angle has a sine and cosine that are both negative? It means in which quad sine and cosine are negative?
210.
Excellent, Al-Walid. In the third quad, because in the first quad, 60 in the first quad. In the first quad, all the trig functions are positive. In the second quad, 145, sine and its inverse also positive, and the rest are negative. In the third quad, sine and cosine are negative, so it's 210, as Al-Walid said. Excellent, Al-Walid. So the answer is letter C. The answer is letter C. Now we will go to our lesson. It's talking about, as I said, it's trig identity. This is the first part of the lesson that we are talking about today. Pay attention about this identity. Pay attention about this identity. First, I'm talking about the value of tan. First, I'm talking about the value of tan. Tan theta, you know that the value of tan is sine over cosine. So tan theta is sine over cosine, okay? Where cosine and sine not equal to 0. It means we don't have 0 in the denominator. The cotan, it's the opposite, so it starts from cosine over sine. So the first identity, it's called the quotient identity. It's talking about tan and cotan. The value of tan is sine over cosine, and the value of cotan is cosine over sine. This is the first identity. This is the first identity. Okay, I'm going to the second identity. It's called the reciprocal identities. Reciprocal identities. Okay, sine theta is 1 over cosec. It means the opposite of the sine or the reciprocal of the sine is the cosec. By the same way, cosec equals 1 over sine. By the same way, cosec equal 1 over sine. Sine theta is 1 over sec. By the same way, is the sec equal the sec of the theta or sec theta equal 1 over cosine. The third, talking about tan, its opposite or its reciprocal is cotan, so 1 over cotan equal to tan, or if you need cotan theta, it's equal to 1 over tan. Okay, so now we talk about number 1, tan equals sine over cosine. Number 2, cotan equal cosine over sine. And this is number 3, the reciprocal of sine, the reciprocal of cosine, and the reciprocal of tan. This is number 1, number 2, number 3, the reciprocal identities. Number 4, talking about Pythagorean identity. It's very important, very important. So this rule will complete with us in this year, in the next year, in your faculty. If you enter any practical faculty, it's a very, very important rule. Sine square theta plus cosine square theta equal to 1. It's related to the unit circle. If we get a unit circle and we make a triangle as we worked before in a unit circle, the unit circle, the hypotenuse is equal to 1. So if we get cosine, which is the opposite or represent x, the reciprocal, sorry, and y, which represent sine, and you make the Pythagoras theorem, it means the two sides square or the sum of the two sides square, it's equal to the hypotenuse square, so it's equal to 1. It's very important. So cosine square plus sine square is equal to 1. Cosine square plus sine square is equal to 1, related to what? To the unit circle. Okay, you can go to the unit circle and remember this part. Okay, from this rule, we can deduce that. We can deduce that 4 rules. The first rule, you can get sine in the other side by the opposite side, by the opposite sign. So cosine theta will be equal 1 minus sine square theta. If we need to find cosine theta only, so cosine theta equal to 1 minus sine square theta. From where I just get sine in the other side by the opposite side. If we need to find sine, means sine square theta equal, get cosine in the other side by the opposite sign, so it will be sine square theta equal 1 minus cosine square theta. Also, if you get, okay, here, divide by sine square theta, both sides. So divide here by sine, and divide 1 also by sine. If you divide sine by sine, it will be 1. And the cosine by sine, it will be cotan. So it gives me cotan square theta plus 1 equal cosec square theta. If you divide by cosine, so divide by cosine over cosine equal 1, sine over cosine equal tan, and 1 over cosine equal sec. So from this rule, we get 4 rules. I can, get out of this show, and I can add slide and write this hint to be clear. Pay attention with me. Pay attention with me. The rule, or the original rule, is cosine square theta plus sine square theta equal to 1. Okay? If you change the place of sign, you will get cosine square theta equal to 1 minus sine square theta. Also, if we need to find the sine square theta, we get cosine in the other side by the opposite sign and leave this sign here. So 1 minus cosine square theta. This is the first 2 rules we can deduce. So from the first rule, we can deduce these 2 rules. Please, if you want to write, I leave it for just 10 seconds. Okay. Also, if I need to find the other 2 rules, pay attention with the other 2 rules in order not to study them without understanding from where they come. Okay, we have here this. If we take this rule and divide here by cosine square, divide here by cosine square, and divide here by cosine square. So I put here down cosine square theta, and here cosine square theta, and here also cosine square theta. Pay attention with me. Cosine square over cosine square, it's equal to 1. Any number over itself is equal to 1. Plus sine square over cosine square, we said before, sine over cosine equal 10. So it will be 10 square theta is equal to what? 1 over cosine square. 1 over cosine is sec, yes. So it's a sec square theta. So this is the third rule. The third rule, divide the original rule by cosine square theta. So it gives me 1 plus tan square theta equals 6 theta. 6 square theta, sorry. By the same way, we can divide, but we will divide this time by sine. We will divide this time by sine, okay? I can leave this for 10 seconds. Okay, so I can here is this. And divide, in this time, I'll divide by cosine. So I divide by sine square theta, sine square theta, and here also 1 over sine square theta. Sine square over sine square is equal to 1, and I have here a plus, and cosine over sine, it's cotan, but it's cotan square, so cotan square theta, and here equal 1 over sine, it's a cosec, so cosec theta. This is the fourth rule. This is the fourth rule. So we have here only one rule. This is called the rule of Pythagoras, which is cosine square theta plus sine square theta equal to 1. From this rule, we deduce another 4 rules. Okay. Okay, let's start to complete Let's start to complete. I return back to the rules. Okay. We stand here. Okay. The co-function identity. Pay attention about this. Pay attention about this. Sine pi over 2 minus theta equal cosine theta. Equal cosine theta. It's a rule. And this rule, we talked about it before. It's called that if the two angles, okay, of sine and cosine, are complementary, it means the two values of sine and cosine are equal. How? Pay attention about this remark. If I said, for example, sine 60, it's equal to cosine 30. Equal to cosine 30. How we get it? 90 minus theta. 90 minus theta. So this rule is very important also. It refers to sine for any angle. For example, sine 60. Sorry for this bad handwriting. Okay, sine 60. It's equal to cosine. It's complementary. The complementary 90 minus 60 equal 30. So sine is equal to cosine if the two angles are complementary. If the two angles are complementary. This is about the co-function hint or co-function identity. And also cosine is equal to sine. It's the same. Okay, and tan equal cotan. The same remark. The same remark. The last one. Pay attention. The last one. Pay attention. Here, if the angle is negative, we want to find a negative, okay, the sign of negative angle, we get the sign value and put negative before it, For example, I need to find sine negative 60. It's equal to negative sine 60. We get the value of sine 60, which is 3 over 2, and put negative before it. So if you have negative angle, and we want to get the sign of the negative angle, the result will be negative. Okay? But in cosine, it's the negative sign. Okay? Because negative angle, it means in the fourth quad. And in the fourth quad, cosine is positive. So if you have a negative angle and you want to get the cosine, it's change it to be positive. Also tan will be negative. It's a very important page. If you want to photo it, and this, inshallah, this video will be on the website SBS. After we have finished, I'll upload it. Okay. Let's go to example. Let's go to a small example. Okay. Find tan theta if sec theta equal negative 2. If sec theta equal negative 2. Pay attention with me. Okay. I return back. Sorry, to the previous. Pay attention about this rule. This rule is representing what we need. Tan theta squared. Oh, sorry, tan square theta plus 1 equals sec square theta. I'll use this rule. Okay. So tan square plus 1 equals 6 square. Tan square plus 1 equals 6 square. Return back to the problem. Okay. So the first step, I write the rule. Tan square theta plus 1 equals 6 square theta. And then substitute. 6 square theta equal negative 2. So instead of 6 square, I write negative 2 power 2. So I complete. He get 1 in the other side by the opposite sign, okay? And then substitute by negative 2 power 2 as you see. Negative 2 power 2 equals 4. 4 minus 1 is equal to 3, as you see. Okay, so tan square theta equal to 3. So by taking a square root for the both sides, square root for tan square theta and square root for 3, because we need only tan theta. So tan theta equal positive or negative 3, root 3, sorry. Positive or negative, so we have two answers, no. Go to the condition. After we have a condition. The condition said that theta is included between 180 and 270. It means theta in the third quad. In the third quad, tan is positive, so we take only the positive value. So theta in the third quad, tan is positive, so we take theta equal root 3. I leave a time to write this example, and one of you help me in the next one. Okay, let's go to the next example. Next example. Okay, it's depend also about. Okay, pay attention with me. I'm just need Nasser and Nasser. Nasser.
Yes, Mister.
Okay, I need, as you see, I need to find sine theta if cosine theta equal negative half, and theta is included between 90 and 180. It means theta in which quad?
I can't hear you, Mister. Just 1 minute. I will increase your volume.
Okay. What about this?
Okay, now. Yes, now.
Okay. So I need to find the sine theta if the value of cosine is negative half, and we work in which quad? In which quad? 90 to 180.
90 to 180 is second.
Is the second quad. Okay, I need to find the value of sine.
Okay.
What is the relation between sine and cosine? Can you give me the rule that get me the relation between sine and cosine?
Sine and cosine.
Yes.
I think sine.
Sine.
ناصر صوتك عالي.
Sine square.
Well, I don't remember the rule, Mister.
Okay, sine square theta plus cosine square theta is equal to 1. It's the original rule. Okay. Sine square theta is missing, so I leave it as it is. This is sine square theta.
Yes, and cosine theta is negative half, so squared, you make it squared.
So I take here cosine square theta, so squared it will be?
Quarter.
It will be quarter 1 over 4. Yes,
equal 1.
1. And then?
Minus.
So minus quarter here.
So it will be 0.75.
Other side. So sine square theta will be?
0.75.
Yes.
Or 3 over 4.
Yes, 3 over 4. But this is squared. I need only sine. So I take the square root of
square root,
both sides. It will be?
Square root of 3 over 4.
So square root over 3 of 3 over 2, because the square root of 4 is 2. So this is
yes.
But don't forget to write positive or negative.
Positive, negative, yes.
Okay, but here, what about the condition? In the second quad, the value of sine is positive or negative?
Second quad?
Yes.
Sine is positive.
So we take only the positive value. We take only the positive value, so I can now write by a good handwriting. We have here the rule. It's a trig identity, as we said together, and then after that you get the value as you make the value of cosine, which is negative half power 2. It's equal to quarter. Then we subtract 1/4 from both sides. We get 3/4 as you get it. So it's positive or negative √3/2, but we work in the second quadrant, so only we take the positive value of
Yes, √3/2.
yes, √3/2. Excellent.
Yes.
So this is the result. If you need to write the result, I can give you a chance to write the problem. This is the last problem today. So today we make a small revision for chapter 9, and we start with some trig identities, and we solve 2 problems together. Please write the answer of the problem. And tomorrow, inshallah, we will complete this lesson and finish it, inshallah. We have an electronic homework on SBS. Try to finish it. Try to finish it. I have only 12 students today. I'll take the attendance now. Okay, my dear students, please try to finish your homework today. We have a small homework on SBS. It's about only 5 items. So please try to finish it today. Thanks, and goodbye.